Hey guys, I know we're not together, but I wanted to get you guys going on this Piecewise Functions worksheet. Taking you through the steps. I know you guys saw the video, but just to get you, sometimes you still need a little bit of help getting started. So let's look at problem one, and hopefully that helps you getting going with these piecewise functions. Again, today we're only going to work on linear piecewise functions. When we come back to class tomorrow, we'll up the ante a bit with our parent functions. So let's look at the piecewise function they gave us. F of x is equal to x plus 5 when x is less than -2. And it's equal to -4 if x is greater than or equal to -2. Okay, so how we're going to handle this, remember, first things first is to graph your breaks, okay, the breaks in your interval. And we know that's happening at -2, okay? -2 is the break in our interval. So I'm going to take -2, plug that into the part of my piecewise function when x is less than -2, and I'll figure out where that breaking point is. So I'm going to find f of the first function of -2. Okay, so the first function, and that is going to be a -2 plus 5, and I know that's 3. So my breaking point is when x is less than 2 is going to happen at -2, 3. And I look at the greater than or equal to sign. I look at that inequality sign. And if the inequality does not have the or equal to, if it's just greater than or less than, then I know it's open circle. So this one is an open circle. So I'm going to go to -2, 3. Okay, -2 up 3, and I'm going to put an open circle there. There's my open circle. Okay, now I'm going to go and I'm going to find out what my break would be, when my breaking point or boundary point would be when x is less or is greater than or equal to 2. Okay, when x is greater than or equal to 2. So that means that I plug -2 into this function. Ooh, look at this. This is an example of what? Well, this is saying y equals -4. So that means for every single x value, no matter what, my y is going to be -4. That means that I'm graphing a horizontal line at -4. This is an example of no slope. So I know f of -2 is at -4. This is our no slope deal. So I'm going to -2, and then I'm going down to -4. And this time I'm going to put a closed circle because my inequality sign is greater than or equal to. Okay, and then now I need to just graph the graph. Now, I can tell you the bottom part is going to be pretty easy to graph, right? Because I know it's just a horizontal line at -4. Now we're talking about all values that are greater than or equal to, all x values greater than or equal to -2. So I know I'm talking about the right side of this graph. So everything on the right side of this line is what I'm going to draw, okay? Bam. There's the first part of my piecewise function. Now, if I want to go to the left side of the graph, that is the x plus 5. I need to get another point. I can just plug in a point on the left side of the graph, values that are less than -2. So here we go. Let me plug in a -3. So if I find f of -3, I know f of -3 is equal to -3 plus 5. Or that is 2. Okay, so I know that at -3, we're going to be at 2. And this is for all my values that are less than -2. So give me my blue pen. Okay, and then I go to -3, which is here. And then I go to 2, which is there. Bam. Draw my point. I need 2 points to make a line. And so I'm going to, again, highlight everything to the left side of this line. There's my piecewise function. So again, go ahead and draw your boundary points or your breaks first and decide if they're open or closed circle. And then draw the left side of the graph and the right side of the graph. Use a one reference point. Okay, use one reference point to draw the graph. Now let's go to the next section, part 2, where they tell you to evaluate the piecewise function. Okay, now look at this. Now I'm going to evaluate the piecewise functions. And I'm telling you, I'm just going to do exactly what it tells me to do. If I look at this function, f of 3, okay, this tells me that I need to find f at 3 with our piecewise function directions. And think of it as directions. So the directions say that when x is greater than or equal to -2, I should be right here at -4. So that means if I plug in a value greater than -2, I need to look down at this part of the piecewise function, okay, the second part. And that's what's happening here. So I know what I'm plugging into is the second part of the function, okay? So f of 3, I go down to the second part of the function because my value is greater than or equal to -2. Well, that's going to be -4 regardless. Just look at the piecewise function, follow the directions. Now let's look at my x value this time. F of -4. Well, -4 is less than -2. So I need to follow the directions of my piecewise function. It says if you are plugging in something less than -2, you need to be up here at the top of the function. Oh, the x plus 5. So I'm going to take -4 plus 5. And I get 1. Follow the directions. Just do exactly what the piecewise function says. This is a trick. Look at them trying to trick us. They said, okay, so what happens when x is exactly -2, our breaking point? Well, I'm not concerned about that because look at our instructions. It tells us what to do. It says, hey, if x is greater than or equal to -2, just be down here, go down here, right? And do the directions down here. And that is what is happening here. Look, x is exactly -2. So I'm going to go down to the second part of this piecewise function. I know this is -4. These piecewise functions aren't so bad. Just think of them as directions telling you to do something. That's all you got to do. Let's look at number 2. Number 2 says, if f is -2, what do you do? Well, let's look at our restrictions and boundaries this time. Now our boundary point is when x is less than 1 or x is greater than or equal to 1. So if I'm evaluating f at -2, I know that's less than 1. So I'm dealing with the top of this function. I'm plugging in -2 into the top part of this function, or the 2x plus 1. And when I evaluate it, I get a -4 plus 1, which is -3. All right, let's look at this next function, f of 6. F of 6, that's greater than 1. So we're going to be working at the bottom function. I'm plugging into the bottom function, or -2 times 6 plus 3. And I know -2 times 6 is -12 plus 3 would be -9. All right, let's go down to the last one. They try to trick us by giving us our boundary point, but we're not confused. We know that the restrictions say that when x is equal to 1, we're down here, right? x is greater than or equal to 1. So we're down at the second part of the function. I'm going to be plugging 1 into the second part of the function. And I end up with a negative 2 times 1 plus 3. So that's negative 2 plus 3, which is 1. Okay. I hope this gets you guys started on the video. You all get this all done with no problems. All right. No problems. I'll see you on Monday, and we'll do a lot of work on these piecewise functions. We'll up the ante a bit, guys. We're going to up the ante. I'm going to include parent graphs. So we're going to make this a little bit more difficult just because we'll talk about different graphs, but you'll notice it's the same stuff, the same thing. And I know you guys can do it, no problem. All right, guys. See you tomorrow.